Welcome, fellow chemists, to the fourth video of my stoichiometry series. Today we will utilize all the skills and concepts learned in the previous three videos. But I must warn you, I'm going to use different equations here, and I won't show you how I balance them, and I won't show you how I found the molar masses. However, links to all videos you may need to rewatch are in the description below. Enough of the chit-chat though, let's get to the first question. Take a moment, pause the video, and give it a go. The first step here is to balance the equation, which turns out to be pretty easy. The next step is finding the molar masses, which is not difficult either. Again, we may not need all of them for this problem, but if we do, at least we have them. We are almost ready to move into the stoichiometry, but there is one last thing we can determine based off the question. We are asked to calculate percent yield, and since there is no context suggesting otherwise, we should expect the yield to be 100% or less. But we are a long way from worrying about that. For starters, there are three values given in the question. We know that this is percent yield, so one of the values must be telling us what actually happens in the reaction. Since the question states that the reaction forms 266 grams of nitrogen, we can identify that as the actual yield. This still leaves two values, both of which happen to be reactants, so this is also a limiting reagent question in disguise. For standalone limiting reagent questions, stick with your preference to determine which one it is. However, for questions like this, the first one I showed you should be your go-to method. Why? In that video I stated, this question gives us two substances but does not specify which substance we want to find. Without a specific substance, we must make an arbitrary choice, but for this question we do not have to make an arbitrary choice because it clearly specifies nitrogen as the product of interest. So we can make our lives easier by setting up our stoichiometry grid to solve for nitrogen specifically. Since 352 grams of hydrazine is mentioned first, we might as well begin with it in our first calculation. After completing the grid to solve for nitrogen gas, the answer comes out to be 308 grams. In the second grid, I need to remove the references to hydrazine and replace them with hydrogen peroxide. This calculation results in 280 grams of nitrogen forming. Because the mass of hydrogen peroxide produces less nitrogen gas, it must be the limiting reagent. That's great and all, you say, but the question does not ask us about identifying limiting reagent, so do we really have to do two stoichiometry calculations in order to determine the percent yield? Yes, we did, but we do not find the percent yield from this calculation. When we identify the limiting reagent, we know that this substance limits product formation. Even though there is enough hydrazine to potentially produce 308 grams of nitrogen, there is only enough hydrogen peroxide to produce 280 grams. By doing the calculation in this manner, we have found the maximum mass of nitrogen this process can produce. That's a fancy way of saying we have found the theoretical yield. Earlier on, we identified the 266 grams as the actual yield. So we can place both yields into the formula, and the calculation results in a percent yield of 95%. This value is less than 100%, which we know is possible, so there isn't much else to do except go on to the next question. Take a look, pause the video, and give it a go. As always, good practice is to balance equations and find molar masses first. Balancing this equation is pretty easy, and the molar masses include two elements and carbon dioxide, which is so common you have probably memorized it already. Now back to the question which, with three values, looks suspiciously like the previous one. It does not use the words percent yield, but it does give us the amount of iron that forms. We can identify this as the actual yield, which means the other two values will once again be used to determine the limiting reagent. However, alarm bells should have been ringing when you read the words propose an explanation. Since we are finding percent yield, if we're being asked to propose an explanation, then we may be headed into greater than 100% territory. But there is no need to jump to conclusions and even less need to reinvent the wheel. We can start off this problem the same way we did the previous one. Let's set up the first of two stoichiometry grids to determine how much iron should form. In this grid, we'll put the 960 grams of iron oxide since it appears first in the question. After completing the grid and solving for iron, we get a result of 672 grams. In the next grid, we replace the iron oxide information with carbon. This calculation results in 728 grams of iron forming. Because the mass of iron oxide produces less iron, it must be the limiting reagent. The 672 grams of iron produced by the limiting reagent is therefore the theoretical yield. The The 681 grams of iron given in the question is the actual yield. Looking at this setup, you know what's going to happen, and the result comes out to 101%. Luckily, the question gives us enough context where this could be a legitimate result. What we need to do now is propose an explanation, or perhaps explanations, for why we have 9 grams of iron above what is theoretically possible. We can start by interpreting the use of the word "you" in the question as referencing a real-life attempt at this reaction. So, what exactly went wrong here? Well, it could be a variety of things, and since we did not actually do it, we might not be able to narrow it down precisely. However, we can try something we haven't yet, calculating excess reactant. We can use the 672 grams of iron that can be produced and find out how much carbon is required to make that much. It turns out that 108 grams of carbon is needed in this reaction. If 117 grams of carbon was used and only 108 grams reacts, then there remains an excess of 9 grams. But we just calculated an amount of iron that also showed an excess of 9 grams. Using stoichiometry, we have possibly identified the reason behind the larger than possible yield. In this extremely hypothetical scenario, it appears we may have produced a theoretical maximum of iron, with the 9 grams of additional mass being contamination caused by the unreacted carbon. Given the common sources of error seen a moment ago, and because we are all perfect humans incapable of error, let's blame the environment instead.
Yes, that will do.
We cannot do better than earning Snrub's approval, so I will bring this basic stoichiometry series to an end, for now at least. The skills you have developed in this series can be used in other areas of chemistry, especially reactions involving gases and solutions. But recognizing and applying context clues specific to those concepts can be tricky. I'm not sure what my next video will cover, so feel free to make some requests, and until I post a new one, thank you very much for watching.